By the time we get done, you will no longer be mere mortals, and you can go see the Selinux for Immortals presentation later on that Forrest put together. All right, guys, I am showing that it is 10:40, so it's time to get started. Again, I want to say thank you very much for coming. I appreciate it. It's fantastic, especially to see so many first-year summit attendees or participants. We really do appreciate you being here. Without you as part of our community, we are not successful, so thank you very much. My name is Thomas Cameron. I'm the Chief Architect for the Western region of the United States at Red Hat. As you can see, there's kind of an alphabet soup after my name. I've been doing this for a little while. Hopefully, if you have any questions, I'll be able to answer them. I have learned the longer that I've been at Red Hat that I feel like the less and less I know. There's so much to learn. But if you have any questions, I will do my best to get an answer for you or give you the answer. If I don't have the answer, I'll get it for you and follow up with you later. So what we're going to be talking about today is security enhanced Linux, and the agenda is going to be a little bit about Red Hat's involvement in the Selinux project. We'll talk about what Selinux is, where it came from, how it works, how to deal with labels, and we'll go over some real-world examples and kind of the common gotchas that I've seen people involved or come to me about when talking about security enhanced Linux. My contact information is on the board. I am thomas@redhat.com. Yes, I've been here for a while. Been here about 8 years. You can follow me on Twitter at Thomas D. Cameron. If you're an IRC user, you can certainly chat with me in #rel on Freenode. I am Choir Boy. There is a story behind that. Ask me at the pub crawl. And my people page is at people.redhat.com/tcameron. This presentation and some of the other presentations I've done from Red Hat Summit are at that page. So feel free to hit it up there. I see a couple of folks taking pictures of the screens. You are absolutely welcome to do so. Be aware that this presentation will also be posted on the Red Hat Summit site as soon as I can get it uploaded. So this will be there as well. So a little bit about Red Hat and security enhanced Linux. Red Hat certainly leads the way in Selinux development. John Dennis, Ulrich Drepper, Steve Grubb, Eric Paris, Roland McGrath, James Morris, and of course Dan Walsh, who is also presenting here at Summit, are all Red Hat, either current or former Red Hat staffers, and they have all been publicly acknowledged on the National Security Agency's website for their contributions to Selinux. And then Red Hat, as a corporate participant in the Selinux community, has also been acknowledged by the NSA as well. So where did Selinux come from? Back in the deep, dark depths of time, about 2000, actually before 2000, the United States National Security Agency provided a set of patches to the Linux kernel using Linux Security Modules, or LSM. In 2000, the NSA actually released Selinux under the terms of the GPL. And it was adopted upstream in the Linux kernel in 2003. Now, one of the things that I find really interesting about the NSA, other than the stuff in the media right now, which we talk about, you would think that being as secretive as the NSA is, that they wouldn't have contributed a lot of this stuff back upstream. The NSA has been a phenomenal member of the open source community. They've done a lot of engineering work, they've sponsored a lot of engineering work, and they've given all of that back to the community. So big props to the NSA. Interesting side story. I am a Red Hat certified instructor as well, and every once in a while I get to teach classes, not nearly as often as I would like to, but I got an opportunity to teach a class in our DC area office. And if you've ever been to a Red Hat class, you know that the instructor will typically do something like say, tell me who you are, tell me where you work, tell me what you're looking for out of today's class. And it's really funny because, you're in the class and there's a guy that's like, hey, my name is John and I work in the financial services industry and I've been sent here because, obviously with financial services we have a lot of needs for security, so I really want to learn more about that. And then the next guy will say, I'm Bob and I work in, trading and we have a lot of financial data, so we need to go there. And you'll get someone that's like, my name is Fred, and I work for the government. Next student, please. So anyway, so it's really cool that the NSA has been as heavily involved in security enhanced Linux as they have. Now, this is kind of where I came from when it came to Selinux. I felt like the 98-pound weakling. I was first introduced to security enhanced Linux before I worked at Red Hat. I worked at a large bank in America. That we were doing security work, and as an architect on the Linux engineering team, I tried, and finally I was like, yeah, so that Selinux thing, turn it off. Anyone else feel that way? Yeah? I get it. But I promise you, by the end of the day, I don't think you're going to feel that way anymore. So if you do feel that same way, you are in the right place. So what is Selinux? Selinux is an example of a mandatory access control system. Historically, in Unix and Linux environments, we had discretionary access control. You have the concept of users and groups and everyone else, and you have the concept of ownership, right? A file or a directory on the file system is owned by somebody, and these are the permissions that are associated with it. Users have the ability or discretion to change those settings. There's nothing at all that stops you from doing a chmod plus rwx on your home directory, and if somebody else wants to access that home directory, you know, you pretty much can do this. In discretionary access control environments, also, root is omnipotent. If you have root access, you have access to the entire system. And I love this Think Geek bumper sticker. I'm going to get that for my truck eventually. On a mandatory access control system, though, there is a policy which is administratively set and fixed. Even if you change the discretionary access control level for your home directory, for instance, if there is a mandatory access control policy in place that's being enforced, you can generally protect even a directory or a file whose discretionary access control settings have been set to being widely permissive. Now, these policies can be very, very fine-grained. We can actually set access between everything from files to users, directories, memory addresses, sockets, TCP and UDP ports, things like that. In Red Hat Enterprise Linux version 6, which is the current version of RHEL, there are two policies that you're generally going to deal with, two Selinux policies. There is the targeted policy, which is the default. Only processes for which there is a policy defined are controlled by Selinux, and everything else is unconfined. That sounds a little weird. Wait, what? Everything else is unconfined? We've got hundreds and hundreds of policies for processes and daemons running on Red Hat Enterprise Linux 6. So that sounds a little scary, but it's actually not. There's policy for everything from system services all the way through Thunderbird and Firefox both have Selinux policies. So it's very fine-grained. Then there is the MLS, or multi-level, multi-category security option or policy that's out of scope for today. I can't really cover that in 1 hour. It can be and generally is very, very complex and typically is used in those TLA government environments, you know, FBI, DOD. TLAs are 3-letter acronyms. All right, so how does Selinux work? You can determine the type of policy that your system is running under by looking at the /etc/sysconfig/Selinux file, which is also symlinked to etc sysconfig Selinux. Or you can run the command status, that'll tell you what the current status is. Or you can just run getenforce, and that'll tell you as well. So the config file that we're talking about is etc Selinux config, and you can see that, if I can find my laser, there we go. Whoop, hello, come back here. The policy set at boot time is enforcing, and the type is targeted. If you run status, it gives you some fairly verbose information about your Selinux status. And if you just run getenforce, it'll come back with an either enforcing or permissive or disabled. It's real simple. So there are two really important concepts to understanding how Selinux works. If you really don't pay attention to anything else today, these are the two things that you really need to understand. Selinux is about labeling and type enforcement, and we'll talk more about that in a little while. Labeling, everything in Selinux, or everything in Linux is either a file or a directory. Really, pretty much everything is represented as a file, right? Except for processes and things like that. Files and processes and ports all have Selinux labels. They are defined they are stored, I should say, as extended attributes on the file system for files and directories and things like that. For things like processes and ports and things like that, the kernel manages these labels. And the labels are in the format of the Selinux user, the Selinux role, and the Selinux type, followed by the level of security, which is optional. Again, that's generally going to be used in MLS environments. For the purpose of this presentation, we really don't care about the Selinux user or role. What we really care about is the type. Remember that we're talking about type enforcement and labeling. So let's take a look at a fairly complex service, one which provides access from the network, potential access to your home directories, potentially access to the rest of the file system. The Apache Web Service is not necessarily insecure. I don't want to give that impression. But what I do want to say is it's fairly easy to configure the Apache Web Service to do, or to let bad guys do bad things to your system, right? So let's look at Apache and figure out how Selinux relates to it. The Apache web server executable, the HTTPD executable, sits on the file system, and when you do a long listing of it with the -Z argument to ls, you'll see that the type is, come back here, is the HTTPD, doggone it, come here. Sorry, this thing's got a hair trigger. HTTPD exec type. Remember that we are talking about the file system, or I'm sorry, SELinux types and enforcement, labels and types enforcement. The web server's configuration directory is also labeled HTTPD config type. Again, right there. And when we look at the log file directory, it also has a type, and that is the HTTPD log type. We start to see kind of a common theme there. If I look at the system content directory, it also has a type, HTTPD system content type. And when I look at the startup script, it also has a label of HTTPD init type. Init.rc type. So that's the file system labels. Remember, those are stored as extended attributes on the file system. Once I kick that process off, once I do service HTTPD start, I can take a look at the process running in memory, again passing the -Z argument to PS, and I see that all of those processes have the HTTPD type. So again, labels from SELinux. If you look at the ports upon which Apache will typically listen, you'll see that even they are labeled. I ran, and this is kind of an eye chart, I apologize, but I ran the netstat command with the -Z argument, and I take a look at the port numbers that it's listening on, in this case 80 and 443, and sure enough, even those ports are labeled HTTPD type. So if I use the semanage command, which is a tool for managing SELinux, I can actually list out ports. I do semanage port -L to list, and I grep out HTTPD, and sure enough, the HTTP port type is associated with 80 and 443, which you're all pretty familiar with, right? That's what Apache listens on. And then also some other commonly used types, 8008, 8009, 8443. So we've done our best to try to figure out what types should be associated with what ports, and we've done a pretty good job of that. Now, changing a little bit, if I go and I look at, let's say, the Etsy shadow file, if I look at that, you'll see that that type is different. It's the shadow underscore type. Remember, we're talking about labeling and type enforcement. So, from a type enforcement perspective, it probably makes sense for a process running in the context of the HTTPD type to access a file with the context HTTPD config type label, right? I mean, that kind of makes sense. Raise your hand if you think it makes sense for a process running in the HTTPD context, or with the HTTPD type context label, to be able to interact with a file with the shadow type label. Anyone? Anyone? Mock them. If they do, just mock them. No. So that's a great example of what type enforcement and labeling is all about. Type enforcement is a part of the policy that says, for instance, a process running in the context of the HTTPD type can access files that are of the type HTTPD config type. But it doesn't make sense for those processes to be able to access your Etsy shadow file. So, how do I deal with these labels? Well, there's a number of things that you can do. You've seen me use the -Z, I should say, argument to several commands to view the context. A lot of commands accept the -Z argument. ls and id and ps and netstat. You can actually use the -Z argument to create context when I copy or move files. So cp-z, make-dir-z, and so on. You can also use SELinux tools like change context or chcon. Remember, we're talking about contexts. To change the context of a file, and I'll show you some examples of that in a little while. Contexts are also set when files are created based on the parent directory's context, with a few exceptions, and we'll talk about those in a little while. RPM can actually set context during installation time. And the login process sets the default context when you log in. Not sure what that is. So, I do want to talk about what we call file transitions. If an application of type whatever, foo type, creates a file in a directory that's labeled bar type, policy can be defined that says, hey, when I hit this rule and that rule, I'm actually going to create a label with the context baz type. So you have to administratively define that, and generally at the level of being beginner with Selinux, you're not going to do that. But a real-world example of this is the DH client process runs with the DH client type label, creates a file called resolve.conf/etc. And that happens when Network Manager logs you into a machine, you get an IP address via DHCP. The DH client utility will ask for the resolve.conf information, it'll write it to etc. Now by default, if there weren't a transition defined, etc resolve.conf would have inherited the etc type label, but instead, because there is a transition defined, it actually winds up with the netconfig type. All right, so you've also seen me use the semanage command. Semanage can be used to manage Selinux context for processes involved in logins, for users, ports, interfaces, nodes, file contexts, booleans, the permissive state, and the don't audit command, and I'll talk more about that in a little while. So what does it mean if I get an Selinux alert? Well, if you see an Selinux alert, it means that something is wrong. Turning off Selinux is like cranking the stereo up when your car is making a loud noise. You can mask it, but it doesn't fix it. You need to figure out what's going on, okay? So it may mean that labeling is wrong. This is fairly common. Use the tools to fix the labels, and I'll show you some examples of how to do that in a little while. It may mean that the policy needs to be tweaked. You may need to enable or disable Selinux functionality by setting a Boolean, and I'll show you some more about that in a little while. It may mean that you need to create a policy module to tell Selinux that you're doing something non-standard. And again, I'll show you an example of that in a little while. There could be a bug in the policy. We do need to know about these. Open a trouble ticket with Red Hat support. Don't just go to Bugzilla. There's no SLA around Bugzilla. So open a trouble ticket with Red Hat support if you think that there's a policy bug, and we'll fix it. And finally, you have been or are being broken into, in which case man the battle stations and remediate the attack. Now you heard me talking about Booleans. Booleans are really just on-off settings for Selinux. From simple stuff like, are we going to allow the FTP server service to access home directories, to kind of esoteric stuff like HTTPD can use mod auth NTLM winbind. We turn a lot of these functions off via Selinux as an attempt to be secure at boot, but you can turn those on or off. Now to see all of the Booleans which are set on a system, you can use the command get sebool, and if you pass it the -a argument, that shows you all of them. Now there's a lot of them. You can see up here, I've just captured a couple of screens, but I mean, you got page after page after page after page of Selinux Booleans. But the nice thing is, they're fairly straightforward. Spam assassin can access the network, on or off. Do we allow, let's see, what's another good example? HTTPD can send email, on or off. There's a bunch of things that are set by default. You can use get sebool-a to take a look at them. To change the setting, you would use set sebool, and then whatever that Boolean is, to 0 or to 1. And if you want to make it permanent, you would use set sebool-P for permanent, and then whatever the Boolean is, on or off, or 0 or 1, and that'll make it permanent. A couple of tips and tricks. If you're going to be playing around with Selinux and you want to learn more about it, install the SE Troubleshoot and SE Troubleshoot Server RPMs. Those include a ton of additional tools and some really, really neat utilities to take Selinux error messages, which are pretty cryptic and pretty painful, and put them into plain text so that you can read them. And then when you're done doing that, either restart the audit D service or reboot the system. I personally don't like rebooting because I'm not a Windows admin. So yum install SE Troubleshoot and SE Troubleshoot Server. And then when you get done with that, you'll get a long list of a bunch of Python utilities, which are really cool, and then service audit D restart. So let's talk about some real-world examples. These are things that I have seen customers, or that I've had customers come up to me and say, hey, I ran into this weird issue with Selinux and it did this thing, so I turned it off. Don't do that. All right. So let's say that I've got this mythical user, Fred, who wants to put his home page into the public_HTML directory under his home directory. So being the good Linux admin that you are, you go and you edit the httpd.conf file, you restart the web server. So I've gone in and I've turned off the user, golly, this thing's killing me. Turned off the user dir disabled, and I've said, no, my user dir is going to be public HTML. I restart the I restart the, I set the permissions on my home directory. You got to grant other access to the home directory so that the Apache web server can go traverse the file system and see the contents of the public HTML directory. Fred logs in, creates his index.html file, and it's in the right location. We've created index.html saying this is my home page. We fire up the web browser and permission denied. Now, typically what we'll do is we'll check the usual suspects. If we're sysadmins, we're going to go look at access log and error log. Unfortunately, this isn't terribly helpful. It says permission denied. Well, yeah, I got that, thanks. And then we go and we look in the error log and, oh, hey, permission denied again. Thank you, HTTPD. Not helpful. So we already knew that. So we get a little desperate and we go take a look at the Var Log Messages file. Now, everyone knows Selinux is really hard, right? Really, this is hard stuff. Selinux is hard. So I go and I look in the log file and it says, hey, Selinux is preventing HTTPD from get at or address on this directory. For complete Selinux messages, run this command. Wait, this is hard. Hold on. So, okay, follow the instructions. And I run the command. Now, it's a big honking text string, so you got to copy and paste. Whoops, hello. So I find out that there are two issues. I love this, though. Selinux is really hard, right? And it says, Selinux is preventing HTTPD from search access on this directory. If you want to allow it to read this content, run this command right here. Type that. Copy that and paste it onto the command line. So, yeah, Selinux is really hard. I'm not buying that anymore. 5 years ago, 6 years ago, I would have agreed with you. Today, not so much. And so, it says, run the command. Now, I do want to point out, if you read that, it's fairly intuitive. Set sebool, make it permanent, HTTPD can read user content, set to 1. That's fairly intuitive. It means that I'm going to allow the web server to access users' home directories. Make sure you understand the ramifications. Just because we tell you you can do a thing. You remember the foot thing there with the don't. Make sure that you understand the ramifications of what it is you're doing. So, it also says that we can create a policy module, but that doesn't make sense right now. We can just set a Boolean. So, we run the command. That's the thing where it says the policy module. So we run the command that it says, follow the instructions and set the two Booleans. We say set sebool, HTTPD is allowed to read user content. Dang it, sorry guys. And then set sebool, allow HTTPD to access home directories. And voila, there's the home page. People say this Selinux thing is hard. I don't buy it. So how can I see what Booleans have been set? If somebody before me made changes to the Selinux policy, how can I see that? Well, those Booleans are actually stored in a file under Selinux targeted modules active. And when you go into that directory, you can cat the file and see what Booleans have been set that are different from the default. Be aware, when it says this is generated by libsemanage, do not edit directly, it means it. This file, if you change it, it doesn't do anything. This file is actually just created kind of as a courtesy so us humans can see what's going on. The actual changes that are made are stored within the Selinux policy file, which is a binary file, and you can't really read it. So don't make any changes to it. In fact, when you run set sebool-p and other commands that we'll talk about in a little while, this entire directory at Selinux is destroyed and regenerated. So even if you did make a change there, next time you run a permanent command, it's going to nuke that directory and start over again. And I just gave a quick example of that. I created a marker file, and then I ran set sebool-p, and I said find everything under Selinux that's newer than that marker file, and it's the whole directory. So it actually literally nukes that whole directory and regenerates it every time you regenerate the policy. So in our next example, we're going to assume that the stuff that we just didn't happen. Let's say that we've got a user named Wilma who's a web content author, and she has created content in her home directory, and she's got it done, and she calls you up, opens a trouble ticket, whatever it is, and says, I need you to move the content over into the production website. You being the good sysadmin that you are, take a look at what she's done. I said she was a web developer. I didn't say she was a very creative one. This is our cool website. But anyway, so you move it over, right? Move the content of Wilma's home directory over to var www.html, and then you go to test it, and Ah, wait, I know what it is. It's the wrong owner because I moved it over, and when you move versus copy, ah, okay, right, it's the wrong owner. So I go take a look at it. It's owned by Wilma. Ah, I know what I need to do. I'm going to chown it, chown root to var www in HTML index.html, and then you go to test and So we go take a look at var log messages, and again it says run this command. Run this command right there. So we run this command, and it comes back, and this time, you know, as easy as I say this thing is, this one's a little bit different. It comes back and it says, wait a minute, user content, what? And then it kind of hits you. Ah, it's saying that I can tell the Apache web server to read user content. But actually, the issue is just that, remember, we moved instead of copying? And so it kept the context of the home directory from which we moved it from. An ls-Z says, oh wait, the type is user home type. Unless we've told Selinux that the Apache web server can access user home type, that's going to fail. So we're going to do one of a couple of things. The first thing we need to do is we need to figure out what the context is supposed to be. Look at a known good file label. If I do an ls-Z of var www.html, for instance, I will see that it's HTTPD system content type. So I can look at the new stuff that I just moved over under var www.html. I can see that it's the wrong content, so I can use the chcon, change context utility. The long form is chcon-u and then the Selinux user, -r and then the object role, -t HTTPD system content type, and then the path to the file. Anyone else hate typing? Anyone else a horrible typist? Because I am. Invariably, this is happening when your boss is standing looking over your shoulder going, is the website up yet? Is the website up yet? Is the website up yet? And you're going to typo like 17 times, right? So I'm lazy. I'm lazy. Remember that. The targeted Selinux role, or the targeted Selinux policy doesn't use the Selinux user or role. So we can actually shorten this up a little bit to say chcon-t and just give the type and then the path to the file that we want to change. So that's better because, you know, I'm lazy and I like to not type as much. But the shortest form, this is kind of cool. You can just say chcon-reference a known good directory and apply that to this file. chcon-reference is awesome. And then it'll go through and it'll fix it. If you just want to, now if you just want to restore a directory and all of its content to the defaults for the Selinux policy that you've got installed, I'm a big fan of restorecon. Restorecon says go read what the context is supposed to be from Selinux and apply it to the file system. So I run that command, restorecon-v to be verbose so I can see what it changed, -r to be recursive, and sure enough it says restorecon reset that index.html file with this user home type over to HTTPD system content type. So when I'm doing things and my machine starts acting flaky because I've moved stuff around and I've done crazy stuff and maybe I've restored from a tar file or something, I run a restorecon against that directory and almost every time I'll find something weird. And sure enough, there is our fancy cool website page, and now the website's in production. Your boss is going to stop breathing down your neck and life is good. Restorecon uses information from Selinux targeted contexts files, file_context, and some other files under that directory. There are over 4,000 entries in that file. Dan Walsh, who is our kind of primary Selinux policy and guru at Red Hat, I don't know how he does it. I don't know how he does it. It's pretty amazing. Don't modify the file directory, directly, I should say. Remember that I said that those changes will be lost? So if you want to get an idea of what it looks like, I mean, it's page after page after page after page after page. But all of the files and all of the paths have some default context associated with them. And I mean, it is page after page after page. It's crazy, crazy stuff. So, but be aware that that's where it comes from. So some more real world examples. Let's say that somebody tells you to create a web directory someplace non-standard. Hey, we've always done it this way, so we're going to put the website under /foo/bar. Okay. So you create the directory, make dir-p/foo-bar, and it's there. I do an ls and I see it. You define the website in the HTTPD config file. I created my virtual host entry and we're good there. And I put the directory /foo, come on, /foo/bar, we're good there. I create the index.html file. I do it in the right directory, and it says this is the dummy host website, so we know we're good there. We restart the web server so it rereads its config. It comes up and it starts cleanly, but you go to the home page and, well, it's not exactly a fail, but it didn't give us that index.html file. So we go and we take a look. Which log file should we check? Var Log Messages, that's right. So we go take a look at Var Log Messages, and sure enough it says, run this command for complete Selinux, run the command, and here's where it does get a little hairy. I'll tell you, this one's a little bit hairy. Because it says, hey, we're blocking access to foobar index.html. You need to change the context of that file, but that file type can be, oh my gosh, any one of these. And at the end, it also tells you to run restorecon. Let me explain a little bit more about that in a second. So when I go and I look at the file itself, how should I figure out what the context should be for that file? Look at something similar, right? I'm lazy. I don't want to have to reinvent the wheel. I'm going to go look at varlog or var_HTML, for instance. And sure enough, if I go look under var_, I see that it needs to be HTTP system content type. Now, we actually want all of the files under foo to have that context. So we're going to use a regular expression. And again, lazy, I cheat. I go and I look at that file contexts file, and I set the context using semanage fcontext. -a to add t type, HTTP system content type, to foo and everything under it. I just grabbed that regular expression from that context file. Now, be aware that you can also, if you're lazy, just use the -e argument, equals. So you can say semanage fcontext add the equivalent of var _, to /foo. I'm a big fan of being lazy. Now, remember that when we use semanage fcontext, all we're doing is we're telling Selinux that files in this directory should have this context. We haven't actually done anything to the file system yet, so we have to follow up by running restorecon. We tell Selinux what the context is supposed to be, and then we set it on the file system. So we run restorecon against it, and sure enough, it goes and it relabels everything to the HTTP system content type. And then we fire up our web browser, and sure enough, there's our web page. In some cases, we may need to actually create policy modules. In the case that a Boolean or labeling doesn't actually fix your issue, you may have to create a policy module. In my example, I set up a Squirrel Mail instance. Squirrel Mail is a great little web-based email client that I set up on a RHEL 6.3 mail server. So I went to go set it up, I went to go log in, and I got an error connecting to the IMAP server. And sure enough, like a good sysadmin, I go take a peek. Now, I looked first under var log audit, audit.log. And in the back row, you may have a hard time seeing this, but anyone want to try to decipher that cryptic craziness? This is what Selinux used to look like. This is what it looked like back in the RHEL 4 time frame. So instead, I go and I look in var log messages, and it says, hey, run this command. And I look at the command, and I figure out that it's an Selinux issue. Here's what I do to keep things sort of realistic. I set Selinux to permissive mode. So I do set enforce 0, or I just set it in etc Selinux config. And I run my application through all of its paces. That way I capture every one of the Selinux denials, right? So I can get a whole long list of the things that have denied. What I used to do is I would leave it in enforcing mode, and I'd run something, and I'd find an error, and I'd create a policy, and that would just expose the next thing that was blocked, right? So put it in permissive mode, run your system through its paces, and then we're good to go. So set enforce 0, and I logged in, and I sent an email, and I read an email, and I logged in from several different users and sent stuff back and forth to each other. And so now I know that Squirrel Mail is working, and I have probably captured all of the Selinux error messages that I can. So I run SE alert, and it gives me all kinds of information about all sorts of things that are not working correctly. But the nice thing is, it actually says, if you want to set a policy module for this, here's how you do it. This is the command you run. Anyone still think Selinux is too hard? I got 15 more minutes. So you run the command that it tells you, and sure enough, it spits out a policy module. Now, I generally, when I'm doing this, when I run audit to allow against the audit log, I will generally set my policy name to be something local. So in this case, I grep httpd from var log audit.log, and then I run it against audit to allow, and I give it a policy name of squirrel local. That's intuitive to me. I know that it's squirrel mail, and I know it's a policy I did. It's not a policy that came from Red Hat. Now, this error could have been fixed by a Boolean, but that wouldn't have been nearly as much fun to demo. So what I wind up happening is I run the squirrel local type enforcement file, and I see that it basically requires for HTTPD and SMTP port and POP port to allow TCP socket connections. It's going to give the Selinux policy, or it's going to set a policy module that allows HTTPD type access to the SMTP port type using TCP sockets in the name connect function. And the beauty of this is, when I run this command, it actually even says, okay, now that you've created the policy module, run this command. SE module install the squirrel local policy module. I run that. I set Selinux back to enforcing. And sure enough, I'm able to log in, I can run it through its paces, I can send mail, I can receive mail, so I have created a policy module for my squirrel mail instance, and it works just fine. So how do I enable Selinux? To enable Selinux, you edit the etc Selinux config file and set Selinux to be permissive. When you go from an environment where you have not been using Selinux to one where you want to turn Selinux on, don't put it on enforcing, because your system will almost certainly not boot, because you're going to have Selinux labeling errors all over your file system. Yeah, that's the voice of experience. I see this guy over here going, yeah, don't do that. So don't set it to enforcing. So what you do is you go in and you set it to permissive. You create a file in the root of the file system called .auto-relabel, and that's just a touch command. Touch the file called .auto-relabel. Reboot your system, and it'll come back up. It will take roughly as long to relabel the file system as it would to do a file system check. It's not the same process, but it runs about the same amount of time. You can also run the command fix files relabel. Don't do that in run level 5, because the recommendation is that we nuke everything under the temp directory, and your xfont server will get really, really cranky if you delete those directories. So, fix files relabel and then run reboot. Once everything's relabeled, set the type to enforcing in etc Selinux config and reboot. Or you can just run set enforce 1 and run it through its paces and make sure you didn't miss anything. It's fairly straightforward. Now, there are some graphical tools available. Even a Windows admin can do this. You can install Xorg, X11, Xoff. And a font, I like the bitmap fixed fonts, or you can just do yum group install fonts, and policy core utils GUI. If you install those RPMs, you can SSH-X into your machine, run system config Selinux, and that's just the installation of the software. You run system config Selinux, and voila. This is great. This tells you what the status was at boot time, what the default is, what it is right now, what the policy is. Do we want to relabel on the next reboot? Guess what? All that does is it touches auto relabel. You can look at the Booleans, see what Booleans are set. And what's cool is you can even look at the file labels. You remember that custom file label that we did? I did a search for foo. Hey, look at that. There's my custom file label that we set for foo and everything underneath it. I can go look at network ports, for instance. And if I look for HTTP port, hey, you remember how we saw 80 and 443 and 8443 from the command line? You can do all this from a graphical UI as well. I can go look at the policy modules which are installed. If I do a search on Squirrel, hey, look, there's my Squirrel Mail policy module. So I can manage all of these things from a remote session. So hopefully, are we there yet? Talk to me after. 1 out of about 110, I'm okay with that. So hopefully, you no longer feel like, oh my gosh, this is so hard. It used to be, I get it, I totally agree. I used to turn this off myself. But the advances that have been made by the community with Red Hat's backing have really made this a lot easier. So, final thoughts, don't turn it off. Selinux has really, really gotten a lot better, and it can save your bacon in the event of a bad guy doing ugly things to your system. It's much easier to use Selinux today than it was just months ago. It increases in performance every single iteration, every release. And this is literally NSA grade security that you have at your fingertips at zero cost. So I hope that you'll take away from this that you'll turn this stuff back on. And if you have any questions, ping me on Twitter, Thomas D. Cameron. Send me email at work, thomas@redhat.com. So there is a pop quiz at the end of this. You have this thing here. The correct answer is 5. If you liked today's presentation, please let me know. If you didn't like it, please give me feedback and bring it to me, and I promise I'll take care of it. For additional information, you can go take a look at the Selinux guide at redhat.com. You can look at the Fedora project Selinux docs, and you can join the mailing list. Also, you can take classes on Selinux. Our 429 class is Selinux Policy Administration. I walked into that class, honestly, pretty nervous. I walked out of it going, okay, this is pretty cool. There are also several videos online about Selinux. Dan Walsh and Dave Echts. Dave is a principal solutions architect. Dan Walsh is the Selinux engineer who does all of our policy. They have done some phenomenal videos online. And then you can also see Dan Walsh's journal at danwalsh.livejournal.com. Again, thank you very much for coming.